Alright, section 13.3, it's really on just one topic. It's a specific type of identity called sum and difference identities. And sum and difference refer to adding and subtracting. So basically we're going to take angles and break them up into the sums and differences of other angles and use those to simplify things. So here are the identities right here. For example, there's three kind of important ones, three angles that pretty much everybody should know when they're doing trig. And these are the three angles: 30 degrees, 45 degrees, and 60 degrees. And these you should memorize if you don't have them memorized already. So I'll show you an easy way to memorize this. Everything is going to be over 2. By the way, these are exact values. You could plug these in a calculator, but most of the time they want exact values. Everything is going to be the square root of something over 2. And here's the only one you really need to remember. If you remember that sine of 30 is 1/2, the square root of 1 is just 1. And the signs count up, so square root 1, square root 2, square root 3, and the cosines go the opposite. Square root 3, square root 2, square root 1. Okay, those should be memorized. Now every other angle can be expressed in terms of 30, 45, or 60. So for example, 15 could be written as 60 minus 45. Okay, or it could be written as 45 minus 30. And if we know 60 and we know 45, which we do from this little chart right here, then we can find out what these equal. Okay, so here are the identities. Basically, if you're taking the sine of two angles added together, that's like the sine of the first, cosine of the second, plus the cosine of the first, sine of the second. You don't have to memorize these. These will be provided, but it's not a bad idea to memorize if you can, but the more important thing is knowing how to use them. Cosine formula is very similar, except it's cosine of both of them minus sine of both of those numbers. And then tangent is tan of the first plus tan of the second over 1 minus tan of the first times tan of the second. The difference identities are on the right side, and these are very similar. We'll refer back to these, and they're also on our trig identity sheet. Where are those? Those are right here, sum and difference, and here they're using alpha and beta. It's in the top right corner, alpha and beta instead of A and B, but they mean the same thing. By the way, this plus or minus right here, where it says sine plus or minus, the plus refers to the top thing, the minus refers to the bottom thing. The cosines are reversed. So the cosine of A plus B, when you expand it out, it turns out to be a minus in between. So let me show you that. It's a little bit clear here. When this is plus, this is minus. When this is minus, this is plus. The signs work the same: minus, minus, and plus, plus. So we'll see how to use these. So sine of 105, first thing is we need to express 105 as somehow the sum or the difference of some of those. And if you look at 105, it ends in 5, so it's probably going to involve 45, and it turns out to be 45 plus 60. So this is the same thing as the sine of 45 plus 60. Okay, what's the identity for sine additions? With sine A plus B equals sine of A cosine of B plus sine of B cosine of A. Again, I'm getting that from this sheet right here. Sine of, it's this top right corner right there. Alright, so let's kind of expand this out, then following the same pattern. That's going to be the sine of A. A is the first thing, so that's our A right there. And that's our B. So the sine of A would be sine 45, cosine of B, so cosine of 60, plus the sine of B, so the sine of 60, times the cosine of 45, cosine of A. Let's go back a second and remind ourselves, here are the ones that we should have memorized: sine of 30, 45, and 60. That's where I'm about to get these values from. And when it says exact value, if you just plug this in a calculator, it's not going to give you the exact value. It's going to give you a decimal approximation. I will show you how to check this though. So this right here, sine 45 is root 2 over 2. Cosine of 60 is equal to 1/2. Sine of 60 is root 3 over 2, radical 3 over 2, and the sine of 45 is the same as the cosine of 45. It's root 2 over 2. So now all we need to do is simplify these. We'll multiply root 2 over 2 times 1 over 2 would be root 2 over 2 times 2 is 4. And then root 3 times root 2 is root 6, and 2 times 2 is 4. So this is the exact answer. We could combine these into one, root 2 plus root 6 over 4. How could you check that in a calculator? So root 2 plus root 6 over 4 should be equal to the sine of 105. So the easiest way to check it is to just plug those both in and verify that we get the right answer. So let's do, first of all, make sure we're in degrees instead of radians, and we are. So the sine of 105 degrees, so what does that equal? Oops, that's supposed to be a closed parentheses there. Sine of 105 is equal to 0.965. Now let's do square root 2. This is our other answer here. Square root 2 plus, what was it, square root 6. And this should be the exact same thing. And this is how we can check it using a calculator. Calculator won't get us the answer, but it will allow us to check it. Equals the same thing. So that's how we can prove that we did this correctly. Alright, cosine of negative 120. So there's several ways we could do this. Again, here's our three main angles here. And a couple ways we can do this. I would recommend writing it like this. I would recommend writing it as the cosine, because it's not necessarily easy how to make 120 using those numbers. It's not obvious. You could write it as 0 minus 120 though. And then let's remind ourselves of the formula. It's in cosine of a minus b, and in between there will be a plus. These are kind of the reverse of each other. So here's the identity for cosine. Cosine of a minus b is this. It's cosine a cosine b plus, even though this is minus here, the identity has a plus in it. Let me get rid of this for a sec. Plus the sine of a times the sine of b. Okay, so even though 30, 45, and 60 were our main angles here, we can still make use of this. We'll have cosine 0, cosine 120. Remember, this is our a and this is our b. Plus the sine of 0 times the sine of 120. How does this help us? We can use the unit circle for this. If we look at the unit circle, here's 0 degrees. Here's our circle. Remember that on the unit circle, sine is equal to the y-coordinate, and cosine is equal to the x-coordinate. It's like in alphabetical order. X comes before y, cosine comes before sine. So what's the x-coordinate right here? The x-coordinate right there is 1, and what's the y-coordinate right there? It's 0. So that means the cosine of 0 degrees, the x-coordinate 0 degrees is 1. And the sine, the y-coordinate 0 degrees is 0. Okay, how do we find 120? Remember we said we have to come up with these angles right here, 30, 45, and 60. So 120 degrees would be about right here. So this angle puts us in the second quadrant. And in the second quadrant, if you remember this acronym, all students take calculus. In the second quadrant, sine is positive, but cosine is negative. So what is the reference angle for 120? The reference angle here is 60 degrees. So the sine of 120 is like the sine of 60 degrees, but in the second quadrant. We already know sine is positive in the second quadrant. So what's the sine of 60 from that table from before? The sine of 60 is radical 3 over 2, although in this case it doesn't matter because this whole thing will be 0. Okay, what is the cosine of 60? Because that's what this is. Well, this 120 is like the cosine of 60, but it's negative. Why is it negative? Because 120 is in the second quadrant, and only sine is positive in the second quadrant. So the cosine of 60 is 1/2, but it's a negative 1/2 because it's actually 120. What's 1 times negative 1/2? It would just equal negative 1/2. So let's test that in the calculator. By the way, negative 120, that's the same as positive 240. And I'll show you that in just a sec. So the cosine of negative 120 degrees should be negative 1/2, and it is negative 1/2. So why did I say that's the same as 240? Because if you went this direction, actually, you know what? Sorry, something went wrong there. We got lucky and got it correct. But negative 120 is... No, sorry, I'm misspeaking. Nothing went wrong. Negative 120 is starting here and going down this way. Whoops, not supposed to be there. Going this way. This angle right here is negative 120. That's the same as if you started here and went the other way, positive 240. Okay, it's basically making them meet at a total of 360. Let's do, I think we kind of did these already. Let's do one more. Let's do negative 15. This is a good one here. So we'll do this. So we want, whenever possible, we want to make one of these angles appear. And how could I get negative 15? I could do that as, let's say, 30 minus 45. I know it ends in phi, so I know 45 is going to be involved somehow. So the cosine formula we just said from before, it's cos plus sine sine. That is our formula, and these are all things that we should know. Cosine of 30 is radical 3 over 2. Cosine 45 is radical 2 over 2. Sine of 30 is 1/2, and sine 45 is radical 2 over 2. If we multiply these, we get root 6 over 4. Multiply these, we get root 2 over 4. And if you combine them into one fraction, you get what they have right there. Alright, here's a kind of a word problem. It says a geologist is measuring the angle between one side of a rectangular lot and the line from her position to the opposite corner is 30. So you can see that picture in the diagram right there. She then measures the angle between that line and the line on the point of the property where a river crosses as 45. So you can see that 45. She stands 100 yards from the opposite corner of the property. So she's at G right there, and that means that this length right here is going to be 100. That's to the opposite corner. She stands 100 yards from the opposite corner. How far is she from the point at which the river crosses the property line? Okay, so that's, we're going to have to kind of read this and understand it here. So she stands 100 yards from the opposite corner. How far is she from the point at which the river crosses the property line? Okay, so let's read this again. She measures the angle between one side of a lot and the line from her position to the opposite corner, 30. That's this one. She then measures the angle between that line and the line to the point on the property where the river crosses. So here's the point where the river crosses. That's 45. She stands 100 yards from the opposite corner. How far is she from the point at which the river crosses the property line? So part of the challenge here is just basically understanding what they're asking for, and that's not always clear. So it looks like that distance y, because it's not clear what they're labeling as y right there. But my guess is y is going to be this distance right here. That's the y. That's the distance that we presumably want to know. If not, we'll correct that. All right, so let's think about this. Well, first of all, this is a rectangle, and rectangles have 90-degree corners. So this angle 30 must be the same as this angle, because these are, from geometry, they're what are called alternate interior angles. And since these are all right angles, that means this has to be 60. So since this is 30, this one would have to be 60 as well, and that means since that's 45, that has to be 15 right there. So that angle y right there is 15. And so here's what we need to do. We need to solve this for, okay, actually I misread this. We need to solve for this length right here. That's x. That's what we're trying to solve for right there. And yeah, this actually, it looked complicated, but it's really not. So we can just do this 30 degrees right here. We know that this hypotenuse is 100, and we don't know this opposite side, x right here. So we're opposite over hypotenuse, that would be sine. So the sine of this angle, sine is opposite x over hypotenuse 100. And I'm not really sure what this has to do with sum and difference identities, but anyway, actually there's probably more to this problem. We'll solve for x first, and then we'll have to find something else as well. So the sine of 30 is 1/2, and if we solve that for x, we'll multiply both sides by 100. 100 times 1/2 would be 50. So that means x right here, let me erase this for a sec. X, this length, is equal to 50 yards, it looks like. So 50 yards is our value. That means this side over here is also 50 yards. That's like the leg of that triangle right there. Okay, so now I see what they need the sum and difference identities for. And we want to find, let me use a different color here that will stand out. We want to find this yellow distance right here. That's what we're looking for. So yeah, this is not a hard problem as soon as you understand what they're actually asking you to do, which was the hard part. Okay, so this angle 15, we're dealing with the side that's adjacent to it, and we're dealing with this hypotenuse. This yellow is the hypotenuse. So adjacent and hypotenuse would be cosine. So the cosine of 15 degrees is the adjacent side over the hypotenuse. And we want to solve that for y. And there's just a kind of a shortcut you can do here. actually, let's find this first. So the cosine of 15 is the same as, how can we make 15 using these three special angles? We could do 60 minus 45, that would work. And let's expand that. So the formula for cosine is cos cos, and because there's a minus here, the formula says that we're supposed to put a plus right here, plus sine sine. And then let's just simplify that. So the cos of 60 is radical 3 over 2, the cos of 45 is radical 2 over 2, plus the sine of 60 is, the sine of 60 is radical 3 over 2. I messed up the cosine here. The cosine of 60 is actually 1/2. And the sine of 45 is radical 2 over 2. And you probably notice, like, a lot of these turn out to be very similar values. We've seen this several times before. This multiplies to root 2 over 4, which we've seen before. This is radical 6 over 4. And we can combine that to be radical 2 plus radical 6. We can't make those into 1 over 4. And that equals this thing. It equals 50 over y. So let's solve that now. Let's multiply both sides by y. And then let's divide by this whole thing. So I'm dividing by radical 2 plus radical 6 over 4. And then I'm dividing 50 by that same thing, radical 2 plus radical 6 over 4. And then what we'll want to do now is try to simplify this if we can. So this starts to get messy with all these fractions. So this is going to equal 50 times the reciprocal of that. The reciprocal of that is 4 over radical 2 plus radical 6. 50 times 4 is 200. Over radical 2 plus radical 6, and when you put that in a calculator, it turns out to be, if this is correct, it's going to turn out to be about 52 feet, or 51.8 yards. That's just from putting that in a calculator. So that's how you would simplify that. That was probably more complicated than it needed to be. I'm not sure you needed the radicals for that, but anyway. Let's do this one right here. So we want to verify, this is another proof here, we want to verify that these are identities. Okay, so the cosine formula says cos, this is a minus, so plus sine, sine. And we want to prove that this is an identity, so let's look at the unit circle again. 90 degrees is up here, and the sine is the y-coordinate, and the cosine is the x-coordinate. So if you look at the x-coordinate right here at 90, the x-coordinate is 0. That means the cosine right here is 0. So 0 times that whole thing is 0. And the sine of 90, the y-coordinate up here, is equal to 1. So this is going to be 1 times sine theta, and 1 times sine theta equals that right there. So that works. Okay, let's look at this next one. Pi over 2 is the same as 90, so we'll just change that to sine of theta plus 90, and the sine formula says sine cosine plus sine of the other one, cosine of the first one. Okay, so this is our formula. The cosine of 90 again is 0, so this whole thing is just 0. Plus the sine of 90 is 1, so 1 times cosine theta equals that right there, equals cosine theta. Alright, and these are kind of done the same way. You do those the same. So that is section 13.3 on the sum and difference identities.